Welcome to the first flash talk in the morning. I'm going to talk about the Breccia-hosted sulfide mineralization in the Cryderman area here in the Sudbury Igneous complex. I'm not going to dwell too much on the geology, but basically, again, we're located within the Sudbury structure that has been interpreted to be the result of a meteoritic impact straddling the Superior province and the Southern province. Cryderman is located in the Southern province, so we're basically going to locate or localize in South Range. And here is a schematic stratigraphic column of the South Range that basically encompasses the main mass units, underlaying, sublayer, and then intruding offset dikes, both of which contain 50 and 50% of the ore mineralization Sudbury, and that intrude into the country rock. But Cryderman is located where? It's located in the south and easternmost part of the SIC. It is underlain by the Stowaway Formation, metabasalts and metasediments, and has in closer proximity, spatial proximity, the Eastbourne Lake intrusion. That was basically layered gabbro-orthositic intrusion. It is also noteworthy to point out that this area is crosscut by east-west postmagmatic shears. Also, one thing that I have to dwell in just a bit is the differences or what Sublayer norite and full breccia are. They both consist of different types of breccias. Sublayer norite, as we said before, encompasses 50% of the resources in Sudbury, but full breccia presents itself underlying Sublayer norite. However, it occurs discontinuous. It's not always found in the South Range. However, it has more representation in the North Range. The fragments, both breccias have the same type of fragments, mostly locally derived from the footwall rock assemblage, but they can present also basic to ultramafic and igneous rocks, cognate class, sometimes even like exotic ones. However, the difference between them relies on the type of matrix. So basically, Sublayer norite presents a noritic to sulfidic matrix, whereas footwall breccia presents an anatectic, so derived from partial melt of the footwall rock assemblages that can be also very replaced by sulfides. So here, just to read a schematic stratigraphic column of the Cryderman stratigraphy. We have four main domains, quartz-rich norite, where we are always coloring. Then we have a transition norite that basically consists of quartz-rich norite with high amount of quartz-spaltic inclusions, probably derived from Eastbourne Lake, we still don't know yet. Then we have a big package of Breccia metabasalt that encompasses the two main ore zones, here ore zone 1 and ore zone 2. And then this unit is bounded by diverse shear zones. In this case, it separates from the more pristine, more massive metabasalts with interlayered metasets. So as you can see, most of the mineralization is hosted within the Breccia metabasalts, but very scarce sublayer has been observed in Cryderman only in one borehole so yet. Here, the sublayer presents itself like very altered with an noritic matrix, blebby, patchy sulfides, mostly peritite, and the inclusions are mostly metabasalts, quartz-spaltic, and then cognate quartz-rich norite. The transition between the sublayer and the Breccia metabasalt in this case presents itself more gradational. So we did some petrography on these units, and overall what we found out is that we have very pervasive alteration, so chloride, epidotes, secondary amphiboles, that basically what it does, it hampers the identification of sometimes the clasts and the matrix. Sometimes, as you can see, for example, in this figure, the boundaries between the class and the matrix are ragged, diffuse, some gradational. Other times we are lucky and we see this sharp contacts where we can see more pristine kind of sublayer material with some OPX. But if we go to the Breccia metabasalt matrix, we present this more intermediate to mafic composition. Again, the clasts are very altered, such as which the matrix does. We don't see really any OPX. Sometimes in the matrix, what we do see is a lot of needly small grained secondary amphiboles, chloride, epidote, clinozoicide. When we go back into the footwall, we find more pristine assemblages, such as like this one, some calcite, and of course, the sulfides. So for now, interim conclusions is basically the identification of these two units, these two breccias, is hampered by this pervasive alteration. The clasts are almostly or completely derived from the full rock assemblages, and for now, no ultramafic clasts have been observed on either unit. Another thing is that no anatectic matrix has been observed so far in the Breccia metabasalts, meaning then that the formation of this unit was likely to happen when the temperature of the SIC was below the amphibolite solidus. could also mean then that the mineralized breccia resulted from probably mechanical erosion of the brecciated fulvo rocks by a sulfide melt. And then the next steps basically determine the composition of relic igneous phases, such as pyroxenes, or maybe we find any metamorphic amphiboles to better constrain these units, and then determine the bulk compositions of the matrices using a combination of different techniques. So, thank you.